This is the fifth video on section 6.2, the derivative. And in the fourth video, we started the process of proving that this function is differentiable. And so we got down to a limit, and we said if we can prove this limit is 0, then we're done. Because then we can use the squeeze theorem. So the first thing I did is I broke this up into two fractions. And so we have an absolute value. So the absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. That's the triangle inequality. So we have this inequality here from the triangle inequality. I will show you my motivation for doing that in some subsequent steps. Now, at this point though, writing this limit takes a lot of board space. And so what I'm going to do here is I'm going to algebraically simplify this term and then go back and take the limit when we're done. So instead of just writing this limit the whole time because it's taking a lot of board space. So I'm going to take this thing that we're taking the limit of right here and we're going to work with it. Now, here's why we broke this up. Because for the first fraction, we can disregard the L squared. So we take away the L squared. That makes the denominator smaller. That makes your fraction larger. So that preserves an inequality. For the second fraction right here, this doesn't, okay, so this didn't have an L here, so we disregarded the L term to make it easier to simplify. In the numerator here, we don't have an H or a K, so we'll disregard the H and K terms to make it easier to simplify. So that's what we do for the second fraction. We disregard the h squared plus k squared. Again, we made our denominator smaller, so we make our fraction larger. So this preserves an inequality. Well, if you take a term, divide by its square root, you get the square root. We don't actually need this absolute value sign here because this term's greater than or equal to 0 anyways. So here we have the square root of h squared plus k squared. For this fraction, what did we do? We factored out an L squared, and the square root of L squared is the absolute value of L. L squared divided by the absolute value of L is the absolute value of L. So this simplifies nicely. And then we go back and we look at the limit. The limit is HKL goes to 0, 0, 0 of this expression is in fact 0. So this function g is differentiable at any point a, b, c. What is the derivative of g at any point a, b, c of x, y, z? Well, remember when we calculated the partial derivatives in the first video? Partial derivative with respect to x is 2x, so we have 2a times x. Partial derivative with respect to y was 2y, and we substitute a, b, c into there. We have 2b, so we have 2b times y. And then the partial derivative with respect to z was 3z squared. So when we substitute abc into that partial derivative, we have 3c squared, then we multiply by z. So this is the derivative of g.